Let's now look at a special case of arrays, and those are character arrays. Character arrays are used to store text, and there's another name for character arrays. They're also known as strings. You've already been using strings here and there, of course, in printf statements. Basically, a set of characters enclosed by double quotes, like this hello over here. This is an example of a string. Strings are terminated with a null character, and I already showed you that in a hands-on section when we talked about arrays a few weeks earlier. The character arrays can be initialized just like numeric arrays that we have looked at just now. But to make things easier, but instead of supplying the value of each element of the array as a separate character put in single quotes, there's a shorthand notation for that. And so you could define a string or character array called string1. You could define that and initialize it like this. And as you can see, this is much more intuitive and much more readable. Now, the string to which we're initializing character array string1 is the string first. Now, if you count the number of characters in that, you'll count 1, 2, 3, 4, and 5. But the length of this string is actually 6 because the last character is a hidden character, and you already know that. It's the null character, which signals the end, marks the end of a string. Now, the null character can also be represented using an escape sequence, and that is /0, similar to the /n, the /t, the /a escape characters, the escape sequences that we saw earlier. Now, whenever you are defining a character array or a string, you should always make sure that it is large enough to contain whatever text, whatever string you plan to allow to store in it. +1, of course. You always need to account for the null character at the end. An alternative way of initializing the string1 character array would be this, but I'm sure you realize that this is very tedious. So it's much simpler to just do it like this. However, both mean the same thing and do the same thing, whichever syntax you choose. When you define a string or character array, of course, you do it just the same way you did it for those integer arrays that you saw in previous examples. Now, remember I told you that it is possible for you to walk off beyond the end of an array because C does not check or does not even know what the length of an array is after you define it. Doesn't keep track of that. You have to do that. Now, when you use the scanf function to scan in, to read a string from a keyboard, you run into the same problem. If you were to just use the scanf function, like this, this would not check whether the string that you're receiving, that you're reading from the keyboard, from the command line, whether that is even within the bounds, within any bounds. So this also throws up a security problem, because if the string that you receive from the keyboard, from the command line, if that happens to be larger than the size of the character array in which you're storing it, you will write into memory locations that you are not supposed to have access to. To work around that problem, what you can do is in the format specifier, you can see over here that we have put in 19 between the percentage and S of the format specifier for a string. What this will do is it will limit the number of characters read from the keyboard to 19 characters, which is fine because the size of the character array string 2 is 20 characters. The last character is, of course, reserved for the null character. So this gets you around that security problem. One other thing that you'll notice is that so far, whenever we use the scanf function, we always put an ampersand sign in front of whatever variable we were reading or storing the value read from the command line to. So we're not doing that over here. And the reason is that when you say string 2, when you only give the reference, the name of an array, that is equivalent to saying this. This is the starting address of the first element of the array. So if you really want to, but no one does that, you could write this over here. This is the starting location of array string 2, if you write it like this. And this is all that the scanf function needs. However, shorthand allows you to write just the name of the array, and that will basically be an address to this location of the start of the string 2 character array. So arrays are different that way, and this is not the last time you'll see this simplification in syntax. Now the scanf function, like I mentioned, will read characters until a space, tab, new line, or end of file character is encountered on the command line. If you use the percentage, if you are reading from the command line, space, tab, new line, end of file. So space, tab, new line, end of file. Like I said, it is your responsibility as the programmer to make sure that the array into which you're reading the string read from the command line is actually large enough to fit the input you're getting. And in case the input received from the keyboard is larger than that, you have to limit, or you have to discard the additional characters by specifying the maximum size of the array you're reading into. And just like we use the format specifier %s for scanf function, we can use it just as easily in the printf function to print out a string which we've been doing for quite a while now. Now, the size of the string2 array over here may sometimes be larger than the actual useful characters of the string in it, of the data in it. When you print out a character array like this, it'll only print out the character until the first null character is encountered. Anything that comes after that will not be printed out. The null character is understood as the end of the data in the string. So in the following program, in the example program, we'll see how you can initialize character arrays with strings. And here's that example. We have over here a string of size, character array called string1 of size 20 characters, followed by another character array called string2. Size is not specified because it is being initialized with these contents: string space literal. This will set the size of string2 to 15 characters. Why 15? Because we have 1, 2, 3, 4, 5, 6, 7, the space also counts, 8, 9, 10, 11, 12, 13, 14, and 15 characters. The 15th is the null character, of course. We then have a printf function that asks the user to enter a string. Now, since the size of string1 is 20 characters, the string we read in cannot be longer than 19 characters. And then we have a printf statement in which we print out the contents of string1 and string2. And we can do the same thing, of course, also using a for loop. So you can really either treat a character array as a string, or you can print it out character by character. And we're doing that over here, separating each character by a space. So if you run this program, you get this message first on the screen. You enter maybe hello there, and string1 is set to hello. String2 is already hard-coded to be string literal. String1 with spaces between characters is hello. And as you can see over here, the there was skipped because we were reading in a string, and the two words over here are separated by a space. So anything that came after the O was basically dropped, even though we had space for 19 characters over there.